welcome to CSI Cambridge Exam Room. I'm your lead detective for this explainer. Today we're opening up Case File, the Failing High Tariff Question. We're investigating the Cambridge AS and A-Level Mathematics 9709 syllabus, and we're zeroing right in on the binomial expansion of 1 plus x to the power of n, specifically for rational n. You see, we're going to treat past papers exactly like a crime scene. These are scenes where extremely valuable marks were tragically stolen by common, entirely preventable exam mistakes. Helping me process the scene today are my two rookie forensics agents. First, we've got Agent Alex, who is completely obsessed with memorizing isolated formulas, and Agent Sam, whose head is always lost in the clouds of vague mathematical theory. Together, we're going to reconstruct the exact moments candidates lose their marks, so you literally never make the same mistakes. Let's get to work.
So why are we prioritizing this case? Well, mastering this single topic accounts for a staggering 15% of your total marks in Paper 2. Yeah, 15%. That's not just a minor infraction. That is a grand heist of your final grade. When Agent Alex looked at this statistic, he practically shouted, "Well, that just means we need to memorize way more formulas." But Agent Sam immediately countered with, "No, it means the binomial expansion represents the universal fabric of mathematics." Okay, reality check, both of my rookies are missing the point here. The principal examiner reports reveal a very specific set of mathematical crimes being committed on the exam floor. To secure those marks, we need a precise forensic investigation into exactly what the examiners are demanding from you.
Here is our official investigation docket for today. 1. Core theoretical foundations. 2. The procedural framework. 3. Top 3 examiners' warnings. And 4. Critical analysis strategy. Let's jump right in.
Section 1. Core Theoretical Foundations. Let's pull out the yellow tape and cross-examine the evidence line by line.
The assessment framework here strictly prioritizes analytical depth over superficial breadth. What does that mean? It means they demand that top-performing students exhibit a connected, conceptual understanding. Earlier, under our UV highlighter, we examined a failed student response for the expansion of 1 minus 2x to the power of -1/2. Agent Alex literally pointed at the monitor and said, "But detective, they wrote down the rational expansion formula perfectly. That's breadth." I had to correct him right there. I said, "Alex, superficial breadth is just writing down the formula. But look closer. They dropped the negative sign when substituting -2x into the squared term. That's the crime." Analytical depth is knowing exactly how to apply that formula to an unfamiliar or complex context. You need connected, conceptual understanding, not just robotic repetition of a formula.
The theoretical architecture of this topic rests on these 3 pillars. Above all, you absolutely must establish causal relationships. For example, if n is a negative fraction, what happens to the signs of your sequence? Well, if the x term is positive, a negative fractional power will cause the sequence's signs to alternate. Why? Because you're repeatedly multiplying by negative values in the numerator of your coefficient. It's cause and effect. Top-performing students don't just solve isolated math problems. They solve mathematical crime scenes by connecting all the evidence together, understanding precisely how fractional powers integrate with other syllabus areas like partial fractions.
Moving to Section 2, the procedural framework. This is where we crack the code on how Cambridge examiners actually award your marks.
Okay, before we reconstruct our next crime scene, a quick directive from the precinct. To ensure you never miss our weekly forensic investigation breakthroughs and always outsmart the examiners, you need to subscribe to Ace the Exams at the handle Ace the Exams right now, and make sure you turn on all notifications. Okay, back to the case file. Let's look at the method mark strategy. Think of this like a standard PEL essay structure. Point, evidence, explanation, link. But we're applying it to mathematics. When we looked at this, Agent Alex was hyperventilating, claiming if the final answer is wrong, the whole question is dead. False. The examiners specifically note that marks are heavily awarded for the systematic process. If you show the correct setup, properly substituting your negative fractional n and your specific x term, you are going to bag method marks, even if your calculator betrays you at the very final hurdle.
Systematic processing follows this exact standardized sequence. Step 1. Deconstruct the question and extract the key elements. For example, if the bracket is 1 minus 3x to the power of -1/2, you need to explicitly write down that n equals -1/2 and your replacement for x is -3x. Step 2. Apply the relevant analytical framework. That means choosing the correct rational formula. Step 3. Execute with crystal clear notation. Keep those negative signs inside the parentheses. I can't stress that enough. Step 4, verify your results for reasonableness. And Step 5, present it with the correct algebraic terminology. Follow this standard sequence, and you lock down the procedure every single time.
Section 3. Top 3 Examiner Warnings. Let's run a live forensic workshop on the absolute most fatal mistakes highlighted in the examiner reports. Examiners consistently flag these 3 critical errors. Mistake number 1 is using the wrong approach for the context. This is the classic trap of treating a rational fraction n like a positive integer n, and illegally trying to use the combinations formula, NCR, which literally only works for positive integers. Mistake 2 is forgetting presentation. Dropping negative signs when squaring terms or leaving messy, unsimplified algebraic fractions will absolutely kill your grade. Now it's time for our first live viewer challenge. I want you to look at a typical exam setup. And, keeping mistake 3 in mind, try to locate the critical trend variable. We're putting a 60-second timer on the clock in your mind. Ready? The mistake is providing generic answers that fail to simplify coefficients specifically to the exact algebraic context given in the prompt. Did you spot it? Always tailor your expansion to the specific context.
Please burn this examiner alert into your memory, because this is where the most mathematical bleeding happens on the exam floor. It's time for challenge number 2. Listen closely to this flawed student snippet we have up on our evidence board and try to pinpoint the technical mistakes that killed their grade. Okay, so the student expanded the bracket flawlessly, they got the coefficients right, but they completely ignored the validity range and confidently stated that the expansion works for all real numbers. Did you catch the error? Agent Sam missed it entirely. Listen, when dealing with rational n, you absolutely must define the condition for validity. The absolute value of your substituted x term must be strictly less than 1. If your bracket was 1 minus 3x, you must state that the absolute value of negative 3x is less than 1, which means the absolute value of x is less than 1/3. Failing to state this validity condition is a massive, completely avoidable loss of marks.
Section 4. Critical Analysis Strategy. Let's perform the final autopsy of our case file and build out your ultimate problem-solving framework. So, to demonstrate evaluative thinking, you need to rely on the deconstruct, solve, evaluate methodology. Top-scoring candidates, the ones hitting those top bands, they don't just quote-unquote do math. They exhibit higher-order assessment objectives. They evaluate their own expansions. They ask themselves, does the sequence of coefficients follow a logical progression based on that specific fractional power? They check their work dynamically by rigorously following this exact framework, step by step.
Consider this your forensic exam protection checklist. Our rookies, Alex and Sam, finally used this to engineer a perfect full-mark paragraph. Let's read it out. 1. Deconstruct the prompt and extract your exact variables for x and n. 2. Solve it in logical, sequential steps, verifying the reasonableness of your expansion at each stage. Seriously, if your coefficients are wildly inflating in a really unnatural way, or your signs aren't alternating when they're supposed to be, you need to catch that error before you move on to the next part of the question. 3. Make justified conclusions by clearly stating your simplified terms and your exact range of validity.
So as you hit the past papers today, I want you to really ask yourself, are you just blindly calculating, or are you actually investigating the validity of your expansion, like a Cambridge examiner? The evidence is clear, the procedural code is cracked, and you now have the ultimate insider's playbook for the binomial expansion of rational powers. To close the case on your A-level revision and make sure you are fully protected, subscribe to Ace the Exams at the handle Ace the Exams right now, enable those notifications, and drop a comment below telling me your current level and your target grade. I'll see you in our next Explainer Masterclass. Case closed.